Hey guys, and welcome to Functional Print Friday. So on the bench this week is my beloved Hakko FX-888D soldering station. And if you're into electronics at all, you probably know that model number by heart because this is pretty much the de facto soldering station that gets recommended every single time somebody asks the question, hey, I'm ready to move on from baby's first soldering iron, what should I get? And this guy overwhelmingly gets recommended because it is, I believe, the cheapest unit in Hakko's line that is a quality soldering station. And it's very no frills. It doesn't have a ton of features. It just works really well. We've got a cord that plugs into the wall. We've got a switch on the side. And when we turn it on, it warms up quickly to the set temperature on here, and we can adjust the temperature. And this maintains that temperature very well. It doesn't overheat. If we let this sit in the base for a while, it's not going to get hotter than that set temperature. And if we're soldering a fairly large solder joint, it's going to put heat into that joint and continue to put heat into it very consistently. I have one problem with a soldering iron, and that is, well, I guess in reality, I'm the problem. I forget to turn the thing off. I have forgotten to turn this off probably 10 times. Over the course of several years, but I think one time I was gone like the whole weekend. And when we did get home from that weekend trip and I realized that this guy had been left on the entire time, I think 3 days in that instance, kind of took my breath away. I realized how fortunate I was that it didn't start a fire. I mean, sure, this part's not going to burn. I mean, this is aluminum. None of this is plastic here. And of course, the soldering iron itself is made from all, at least flame retardant materials, even up the handle. But this is open at the top. It's open at the top so heat can escape while this guy's on. If this was closed in some fashion, heat would build up in this guy and it would be unsafe for other reasons. And any number of things could happen, right? I mean, this is in an unfinished area of my baseness. That's where my electronic stuff is. Some piece of paper or light material or insulation or something could, float along from a draft, fall into here, catch fire, and start something else on fire. So I'd like to come up with something for this soldering iron that will automatically turn it off after a preset amount of time. And I've got some ideas. What I'm thinking is some sort of base that this guy sits on. And in that base, I would incorporate probably the same timer board that I used in my UV curing station build. I'll pop a picture of that up here on the screen. It's just like an IKEA steel frame box with a 3D printed part on the top that has the timer board integrated into it, and you flip it on, the board powers up, push a button, and it starts counting down. And while it's counting down, the relays are closed. Actually, you can wire it normally closed or normally open, but the relay stays in that position after the button's been depressed for a set amount of time. So I'm thinking we could program this to, I don't know, maybe 15 minutes, something like that. And I'd flip it on, hit the button. This guy would power up because this is just a dumb switch here. This doesn't have like a digital start or something like that. It's just a dumb on-off switch. So I could leave this on all the time. This would plug into the accessory I want to make. This would turn on when that timer circuit comes on. And then if I forget to turn it off, it's just going to turn off automatically after that timer expires. And if I'm still sitting there doing soldering, maybe it's a larger project and I had to go get some other pieces, or it's just that much soldering that I'm still there 15 minutes later, I can just come tap that button again and this guy will power right back up and run for another 15 minutes. Let me go grab the timer board that I'm talking about. All right, here's that timer board that I'm talking about, and I bought 2 of these when I did the UV curing chamber build. It's been a little while since I wired this guy, so I'm not sure I remember all the connections, but I think this is our DC input on this side to run the board. I think it was like around 12 volts or a voltage range around 12. These buttons program the length of the timer. We have a relay on here, and I think these are the outputs for the relay. Again, I think there's a normally closed and normally open option. And the reason I'd like to use this relay, well, twofold. I have one. And secondly, I've already done all the design work in that UV curing chamber build to mount this guy. I can just steal all my design work for the timer board part of that. Like sort of the bevel that comes down for the display, the lineup of the buttons and the actual plastic buttons themselves that push down on these micro switches, and all of the mounting points that come down to secure the board. So that should save us a good amount of work in this design. And I know this works. I've had this on my UV curing chamber for years. Works very well every time I go to use it. All right, so I think the next thing to do is to get some measurements off of this. Again, I'm thinking of base, like something that would sit underneath of this, and I'd like it to key into it. So I'll need to get some measurements of where these feet fall, and they are a little bit different from front to back. You see it has, these are a different shape than the ones on the back. So we'll need to measure that, and I'm probably gonna have to go bigger than the base of this. Just looking at the timer board here. Yeah, I mean, once I have sort of the walls of the case and have room for the wiring, the base is going to be bigger than the soldering station itself, but it shouldn't be a ton bigger. I think we'll be okay. And let's see what the rating is on this guy. So this is 70 watts. So that's not that much power. I never trust these relays for anything near what they're rated, especially in AC. But yeah, this is rated at 10 amps for 125 volts AC. We're nowhere near 10 amps, so we should be fine switching the mains with this. We'll put a fuse in the circuit as well. So, all right, let me go fire up the design software and see what I can come up with for a first draft. Oh, almost forgot. I have some other parts I want to design around left over from my pile of stuff from other builds. So this is the power outlet that we'll design around because of course we have to have a way for this to plug into whatever we're going to build for this guy to sit on. I don't want to just like cut this off and hardwire it in. Let's see, I have the switch that I'm thinking to activate the timer. This is actually the same type of switch that I have on, again, my UV curing chamber build. I think this one's blue. I think I had bought a couple different colors when I did that build. This one's either blue or red. I don't remember which one, but either one will be fine for this project. And I also have a whole bunch of these style switches. I think I bought a bag of 30 of these at some point. We'll use this to switch the power to the base. So we'll have power coming into it. It'll go through this first. When this is turned on, the timer board will energize, and then it'll start the countdown timer when we push that smaller button. This should also be rated for mains current as well, but I will check that to make sure we're good. And we'll probably need something like this for where the cord, the power cord, enters that base. And for the power cord itself, I've got a whole box of PC power cords, the power cords that you get with a computer power supply. I just cut them off and use them for projects like this. Don't throw stuff like that out. I mean, not that it costs that much to buy one of these, but you'd be surprised how much use I get out of just extra stuff like that. Just keep it somewhat organized. I have mine in old boxes, just on some steel shelving in my basement, and I can go to that and just grab stuff like this when I need it for projects. So, all right, let's go draw. All right, guys, I screwed up. I somehow forgot to hit the button to record before I started drawing, but here is what I came up with for a first draft, and I will just give you a quick walk through it. So, talked about it basically just being a base that sits underneath the Hakko station, and that's what you're seeing here. So this is the top surface, and these recesses here are for the feet of the soldering station to fit down into. Try to get a little bit cute here with the bump out for that momentary lit button that will start the timer, and the design here for the actual timer board I was able to basically just steal. I went back and got my my design work here from when I did, again, the UV curing station. I had already modeled out the board, figured out where all of the standoffs need to be, and designed the actual push buttons for this. So basically just grabbed that and grafted it onto the flat front of this. Let's see here. So inside, this is the bottom. I did not design the actual bottom part yet. I kind of stopped myself. I kind of get obsessed with this, some of the fine details. And then oftentimes I'll reach what I think is a finished product, print it, and realize that a lot of things don't fit. So I need to go back and adjust them and then undo some of the aesthetic or just, you know, finer design points. So I stopped, figured, let's go ahead and print this in this version, test fit everything, and then see what we need to adjust. I also didn't really spend any time at all, you know, thinking about the 3D printing process from an overhang perspective. I mean, I did for the broad strokes, like the case itself. This is going to print. So this is the top, but it's going to print, you know, face down on the print bed. It's got a bevel all the way around, and then the lip up here for the bottom will be facing up. And I did put some thought here into putting some drafts in so that we don't need supports. But I didn't mess around with the supports at all up here in the front, or I should say mess with the design to minimize them, because it's fine. I'll just let the slicer generate the supports, and we'll figure out what works, what doesn't, and what needs to be adjusted. Let's see, what else? Yeah, I thought about trying to have like a pocket or something inside for that transformer. I don't even know what I'm going to get yet. I need to get on Amazon and look at what options there are. This is going to be pretty tight inside. Let's see. So this is, what is this across? Almost 100 millimeters across in this direction. And in this direction, we've got about 125 millimeters of space. So, I mean, it's not like super tiny, but we don't exactly have a ton of space in here either. I don't have room to, wire in a wall wart or something like that for an AC adapter to get us down to the 12 volts DC, especially when you consider the space we're going to lose to wiring in the switch, wiring in the outlet back here, the power cord coming in through that cable gland, and then all of the wiring up here. We're not going to have a ton of room left over in here. So I need to find something really small to get us that 12 volts DC to feed the timer board. So I'm not sure exactly how I'm going to do that yet, but there should be room in here somewhere. I'm also pretty pleased with the aesthetic, but I often say that and then do a test print and realize I don't like it. So we'll see what happens when I print it. But enough talking about it. Let's get this printed out and see how it's looking so far. All right, here is that test print, and I fiddled with it a little bit last night. It's the next day, and I think we're close on stuff. I did make some mistakes in my design here. I don't know. Somehow I ended up with the radius instead of the diameter for this hole. There's no way that this cable gland is going to fit in that hole, and I don't think we have room for the cable gland to go here. It looks like there is from the outside, but when you consider that step on the inside for what is going to be the bottom, there's just not enough room there. So we're going to have to figure something else out for that. Maybe we'll come through the side or the back or something. But this looks like it should fit, so we can just move that hole. It's a tight fit, but that's good. That's what we want. This guy should click into place. Maybe we'll just move that hole up to the center, the square hole, since now we're not going to have this one here. I also missed that on the, here's a problem we're going to have to solve too. So this lifted from the bed. I've got to hold it the right way. You can see it lifted over here, and it lifted over here. I think if I just add a skirt around this, maybe 3 or 4 layers thick, that comes right up to the edge here, and comes over maybe 1/2 inch. That should give us the holding power that we need. What's happening is, because this is so tall and it's hollow on the inside, it's the stress in the material is lifting this up off the bed. I've had that happen with other prints before too. Usually the skirt solves it. What else? This hole here for this button. So this is going to go in from the outside. It's not going to work as is. I was thinking that the button, these tabs on the side, could line up with our larger material here, but in my infinite wisdom, it was not occurring to me that that means then that the power button is going to be sideways like that, which is no good. So we'll have to adjust that so that this guy, that there's room in here for the locking clips to expand and hold this guy in place. And our timer board. Oh, another thing. So I let it just put supports in here wherever. Oftentimes in a draft print like this, where I'm just kind of trying to get an idea of how things are going to fit together, I won't spend a lot of time on designing it to minimize supports. I'll just let it go the first time, see what other things I need to tweak, and then in the final design, really think more about the 3D printing process and make sure that I don't have material kind of hanging in places that's going to need to be supported. Because there ended up being a ton of supports up here in the front part. And even after removing them all, this doesn't quite fit. It's close, but if you guys can see, we have a gap right here. This side's good. This side there is a gap, and what's happening is the relay is hitting up here in the front of the case. So we'll need to relieve that a little bit more. Also, the buttons all line up. Everything is good there. You can see them there through those holes. There'll be actual buttons, 3D printed buttons that come up through these holes to actuate those buttons, and they'll essentially be trapped in there. So the spring action from the micro switch will return them to the correct position. And you can see we'll see our display through that. These four bubbles that bring us down to the display. I also really ended up liking the aesthetic of this part here, but it looks small. It looked good in the design, if you can imagine that guy in there, and the metal nut will be on the inside. But I think I want to double down on that aesthetic. This just looks too puny. It looks, I don't know. I like the idea of breaking up this curved corner, but I think it just needs to be bigger or stand out more in some fashion that just makes it even easier to come in here and hit it. Honestly, that's more aesthetic than function. It's not really going to change the function that much, but I want to tweak that. I like it, but I need to go, I think, bigger. What else? Well, we got to figure out the cable gland, how we're going to mount that. That's going to be a little bit of a pain because it's a curved surface on both sides, of both the outside and on the inside, and it's thick. That cable gland, what do I do with that guy? That cable gland is only so deep. So this is the part here on the back that's meant to go through whatever you're mounting it on. So we'd have to really thin that out to use this. Just for comparison, you could see we're not even close. This would have to be at least twice as long, the threaded section, to go all the way through and give us room to put the nut on. So might need to rethink that. What else? Oh, well, we need to actually design the bottom. I didn't even bother trying to draw what the bottom is going to be. I mean, that shouldn't be particularly hard. We can use the outline here from the inside. Just inset it a bit so we have clearance and draw that. And then we're going to need some sort of feet. I'm thinking probably TPU for the feet. That shouldn't be overly difficult to do. And what else? Oh, I'm going to have to figure out how to wire this. It shouldn't be super complex. I just need some time to think it through. Oh, and we're going to need another piece too. This runs on DC, and we're basically just switching AC for this. So let's see if I can oversimplify this. We're going to have our power coming in. So this will plug into the wall. Our power is going to come in somehow. Haven't quite figured that out yet how. The power will be switched by this guy. This switch over here in the side. Let me move the camera so you guys can see better. Okay, so power comes in. Power goes through this switch. Okay, and then the power is going to need to split off. One of the power leads is going to go through the relay, so this relay can switch it, but we also need to power this board somehow. So we're going to need an AC to DC converter in here. We're going to need to bring that 120 volts AC down to whatever the input range on this is. I think it's 12. So we'll need a transformer or something. I have to find something small that fits in here because this is pretty small. There's my hand for scale. I mean, it's bigger than the footprint of this, but it's still pretty small. So we'll need to figure that out. I think we're also going to need a resistor for this switch. The switch is lighted, and I believe this is a lower voltage input. It's probably like logic level, like maybe 3 volts. So we'll need a resistor for that. And then the wiring, well, the neutral and ground will be tied together with the incoming neutral and ground. And then we'll have the hot coming from the relay so that it is switched. Probably forgetting something else in there, but we'll figure it out as we go. So yeah, I think let's go back to figuring out how we're going to solve these problems. All right, guys, and here is the next version of the design, and hopefully the final version of the design. And I might have gotten a little bit carried away with some of the details here, as is often the case. I sometimes just have to remind myself that I'm only designing this just for me and to share with you guys here on the channel. It's not like this is actually going to go into production as a product or something. But let's take a look at some of the changes that I made. So first thing here is the aesthetic on where that button is poking through. And I did make this portion of it, this sort of arc here, larger. I also added an inset, and then this is actually with the actual hole where the button goes through is slightly then recessed from the face, so that with the thickness of the end of the button, it just sits just slightly proud of this front face here. I also added the buttons in for the timer board, just to get an idea of what it's going to look like. Colored the numerals. I actually have a dummy timer board inside there that, again, I stole from my design from when I modeled this board for the UV chamber. Oh, I forgot to mention when I showed you the draft version of this, the actual soldering station didn't sit correctly on this. When I originally measured it, I didn't realize that there was like two sort of tabs that stick out of the bottom that were hitting against the top of our base here. So I had to add a recess for those guys. So hopefully the base station should sit nice and flush on this now. Speaking of getting carried away, let's pull the bottom off. Let's see here. We can leave the feet there. They're not really in the way. So rather than figure out how I wanted to adjust the design to have that cable gland, I figured, why not design my own cable gland? So that's what I did. And I don't know how well this is going to work. It's a combination of a couple different elements. So this piece here will be in TPU and will hopefully act as a strain relief on the cable as well. The black part is our power cord coming in. And that TPU piece will slide in from the inside. It should lock into place. I'm assuming it's going to be flexible enough, hopefully, to clear this part here. If I hide the cable, you can see it should push in and then lock down in place here. The cable will then feed through, or maybe I'll feed the cable through that strain relief first. We'll have to see how that works out. I'm not sure how tight things are going to be either. But then the cable will sit, go back and unhide that. Get rid of our bottom again. And then the cable will sit on sort of this, this recess here. And these holes are designed to feed zip ties through so that we can basically zip tie the cable to the inside of the case. This block here is just, this comes right off the floor, or actually down from the top of our enclosure, since we're looking at the bottom here, or sorry, this is the bottom that I had hid. This is the, we're looking at the inside of the top down here. Again, this is our top surface here. So we'll see how that works out. If we have to make revisions anywhere, it's probably going to be there, as I don't know that the TPU is going to be the proper fit for the power cable, or the proper fit and flexibility to feed into there, but we'll give it a shot. The feet are also designed to be printed in TPU, and if I bring back our bottom, they're just a pressure fit into holes here at the bottom. If I hide one, you see they should just press right in. I didn't design any clearance into those at all. I did in the actual bottom. You can see we have a point, I think it's a 0.1 millimeter gap all the way around, which gives us 0.2 millimeters total of play in the bottom cover. I didn't do that at all on these for two reasons. Number one, I want them to be a really tight fit. They shouldn't be removable once they're in place. And number two, TPU tends to shrink a little bit when you print it anyway. So I think once we push these guys in place, they should be a good fit. I did make kind of one mistake where I positioned the holes for the bottom cover. If you notice, I centered them in our sort of shelf here on the inside that bottom cover is going to fit on, and I didn't want to make the shelf any wider when I designed it. I'm kind of regretting that decision now, or not going smaller with these holes. These are sized for M4. This is actually, I designed the holes to be the tap size, so when I tap these out, they're actually going to be, the threads are going to be a little bit larger, and I'll just tap those out with the same tap that you would use if we were threading, actual holes in metal or some other material. So they'll get done after the print's done. So if I bring that bottom back, you'll see what I mean. I didn't have quite enough room to actually have the cutout for the bolt that's going to go in there, the M4 bolt, without relieving it here at the edge. And it also meant I don't have a ton of meat down here at the bottom to hold this guy in place. I think I left maybe 1.5 millimeters down here. Now that should be enough, because gravity is going to be pushing down the weight. Again, this is the bottom, so gravity is going to be pushing down on this. So this guy really just needs to stay in place when we screw it into position, and then set this guy down, and the iron's going to sit on the top. And I decided to come up basically proud of the bottom of the base here, and then put a bevel on it to give us some more room for these feet to push into. And it should just kind of give us a nice shadow line under this guy as it sits on the bench as well. Let's see, what else? Okay, so I got rid of the hole up here that was the wrong dimension for the cable gland, beveled this out, moved the square hole for our power outlet up to be centered in this space. It's not going to be centered on the rear, because again, we lose all this real estate up here to that shelf for the bottom cover to fit on, but we have plenty of room now for that here. I brought these sides over so that we have room for the switch to click into place. I also made the diameter of this hole just slightly larger, and in fact I did the same thing for this one as well. The switch was, that momentary switch was a real tight fit in here. This switch over here fit okay, but it seemed like I wasn't going to be able to push it all the way in to lock it in place without a little bit more room. Let's get rid of the dummy board here. Made a bunch of changes up here so that we could eliminate the majority of the supports. I put the relief in here for that relay to push a little bit into this, this recess here. If you recall, the board wasn't going all the way up against these standoffs on this side because that relay was hitting against the front. I beveled that so we don't have to worry about any material kind of hanging here. and I extended these standoffs. These were just round and coming off the front face before. I extended these all the way down to, in this case, what is the top, but will be the bottom of our print. I also extended these all the way up to here so that at least they are supporting this upper part here. We are still going to need supports in here. I could not fill this with material because on that timer board, that's where the actual screw terminals are. There's a set of screw terminals on this side for the relay, and there's a set of screw terminals on this side for our DC power input. So I need that room there. And that's why there's this gap over here too. I'll wire the board before I screw it in place here on the front, but we still need clearance for those wires to exit those screw terminals and come back into the rest of the case. Same thing on this side. Might be a little bit tight over here because we'll have the wires, the thicker wires, coming off these screw terminals for the switched AC. And then we'll also have this switch poking through, but there should be enough room in there. And then I made a lot of changes around this inset here for the display. On the original version, this was just a thin inset that came in with no material around it. I extended this all the way down to the floor of our print, which again is the top, and then beveled this over to support this section up here, and then made this basically all solid material where those buttons push through. There's nothing there on the board that we have to avoid. This whole section of the board, there's nothing but those surface mount micro switches where these holes line up with. And then the buttons, let's see, we'll go back to this view, hide this. You can see then those plastic buttons, there's actually a gap there. The buttons feed in from the inside. They poke through. They're not attached to the actual frame. And then the board screws in place, and then these buttons are essentially just trapped in there. The only thing they can do is move inward, and they're stopped by that micro switch. So when you push from the outside, they depress the micro switch, and then the micro switch pushes them back into this position. All right, so I do feel like I'm kind of pressing my luck a little bit with all the different changes that we made on here at once. And I even went and did all my finished bevel work and stuff like that I normally wouldn't do until I know for sure that everything is actually going to fit together as designed. And I wouldn't be surprised if we're back here, at least making some adjustments to the fit on these TPU parts. Yeah, that's where we're at. So I think I'm going to stop the video here. I think this is going to be 2 parts. This video is getting a bit long. I'm going to go slice this outer case, get it printed out, and by the time I bring you back next week, I'll have all the parts printed out, and we'll be ready to test fit things together and get this assembled. I still need to order an AC transformer that's actually going to fit in this case as well, and then test fit everything. So next week we will finish this out. I'll make sure that all these pieces fit long enough before next Friday that I can make any revisions if needed, so that next Friday you guys are looking at a finished functional product with the base station sitting on top and everything hopefully working. I know we usually get things done in one video on this channel, but again, it's just, this was really starting to kind of feel pretty long with all the work that we've done. There's a lot of complexity here. This is not just one part that's adding to the functionality of something. It is a whole from scratch design, and we still got to wire it and actually build everything. So guys, thanks for hanging out with me in the shop this week. If you guys aren't subscribed to the channel, now would be a great time to do it so you can catch the rest of this build. And you know, outside of this build, if this is your first time on the channel, I do a new video like this every single week that is a functional print. It's either adds functionality to something that I've picked up, you know, that I feel like could just use a little more, or is an add-on part or accessory to something, or sometimes a totally from scratch design like this that fulfills some function that I wish existed as a product. So if you're into that sort of thing, at least go hit that like button, because then YouTube's going to show you more stuff like this. And if you liked this video, if you like listening to me drone on about this stuff, hit that subscribe button. And if you do, guys, I will see you next Friday.